All right. Thank you all for coming today. My name is Chris St. Amand. I'm the CTO at Smart Data. Glad you could all be here. I'm happy to have Dr. Phung. Dr. Phung is an associate professor in the Department of Computer Science at the University of Dayton. He is also the founder and director of the Intelligent Systems Security Lab. His research has spanned security solutions for intelligent web, mobile, and IoT systems. He's also interested in malicious software detection and prevention. His works have been published in top tier security journals, and he has presented at a wide variety of security conferences, including the upcoming Ohio Information Security Conference on March 13th. So he will be there. So if you're going to be there, also check him out there. Dr. Phung has served as a reviewer for many top security journals and conferences. He's on the program committee for over 20 international conferences. He has been invited to talk in many reputable institutions, industry, and academic venues, and we are pleased to add Smart Data to that list. Dr. Phung has been elected as a senior member of IEEE and ACM, so thank you very much for agreeing to enlighten us today. Software security and ethical hacking for developers.
All right, so thank Chris and thank everyone for being here. Thank Smart Data for having me today. This is my second time here. So last time I was here, listen to someone else talking. So now it's my pleasure to talk. Let me do it again. I have this site set up for you to do the real hacking. What I mean by hacking, then I do real hacking. So if you have computer or even a smartphone, that will work as well. So today I'm happy to talk about software security. That is one of my research focus, but also my teaching interest and teaching experience as well. And I talk about hacking for developers. So that is one of the topics that I mentioned in my course at UD. So let's start with cybersecurity in general. So when people talking about cybersecurity, most likely they mean about how a hacker hack into a company system, steal data whatsoever. And I mean that's not wrong, that's right? But that is more likely about network security, because people come from outside and then steal information from inside, right? And I have this table for you to see that companies enterprise, they spend a lot of money to protect themselves, of course, and that's right? But the issue nowadays is that most of the cyber attacks are not due to the network security because it's already secure. So you can you guess what most of the attack come from? It's come from the applications, and that is another statistics. Is the application nowadays are the weekly cleanup of the company, because they already protect the infrastructure, but it's not ignore, but I mean put less care about application. And if you see the chart over there, like web application or software vulnerability are some, I mean even top of the attacks, like more than 50% of the attack come from applications, right? And here are some common software vulnerabilities according to Cisco research institution. buffer overflow or buffer error top, and then input variation is another one, and a lot of other things. So today I will cover some of these topics, like like for example buffer overflow or input variation. Um, what lead to the what kind of these vulnerability lead to the real attacks, right? And I will talk a little bit more about how I integrate this topic into the course, so that students at the future developer can aware of this and can avoid this. I mean, in the future. And today I want to share with you so that maybe you are aware about. Maybe you already know, but maybe you can get something new, right? So let me have this diagram to uh, say one more time about the difference between software security and network security or cybersecurity that people think about, right? So when people talking about cybersecurity, they care about, like not inside the application, but software security is the problem inside the application. That because it's inside the application. So network security cannot cover the problem over there. So so I can give you one example, like why network security in general is not sufficient. I mean, it's not enough to protect people or protect the company. So here is a real world example. It is not recently, it's kind of long time back, but it's happened. Like let's say you are the PayPal user, PayPal, right? You have a PayPal account. So PayPal is like financial company, right? So they deal with real money. And let's say, of course, PayPal, they pay a lot of attention for cybersecurity. Let's say they require the customer to have a two-factor authentication. Let's say after you log in, you have to push into the phone so that it's you. So it means that, like, if someone steals your username and password, it cannot log in. So it's very secure. So the scenario is like this. So one day when you are, let's say, when you are on PayPal and you receive an email from, let's say, your trusted friend or something, they give you a link like this, right? PayPal.com and whatsoever. And let's say we are IT people, and we know that this is not phishing. This is the real link. So you know that this come to PayPal. It's go to HTTPS. So the quick question is, do you think that is safe to click on the link?
I would say probably the fact that it's coming from my friend.
Check to PayPal.com, of course. It will be go to PayPal.
What is it pointing to?
What is it? No, real. So what I'm saying is that at the IT professional, you know that it's come to PayPal.com. It will not come to somewhere else. It's not a phishing. I mean, it's real. It's real link. Real link to PayPal.com. No. That's what I said. This is the destination. No, this is destination. This is the destination. Yeah, it's good check there. Click. You lose some money. You lose some money. So that was the attack happened in PayPal before. It's called cross-site request forgery attack. So what happened was, and this happened not only PayPal, a lot of banks, they have this problem. The problem was, let's say you couldn't log into the system, and then you click on the link. So when you click on the link, your browser will send a request to the server because you went to click on the link, right? So in that request, what it said, hey, transfer money from Chris to Phu. And it does, because you already have a two-factor authentication, but the system didn't prevent from this attack come, because this attack not come directly from PayPal.com. It's come from when you click the link. It's come from your another browser or another app, and then it's go to there, and it happens. So in the past, PayPal vulnerable to this, and then when the victim click on the link, the victim lose the money to the attacker, and that is one example of the vulnerability in software, and of course you see that this is HTTPS, this is two-factor authentication. It's not sufficient, right? Yes.
Sorry, I'm not understanding. Is there something in the middle that presents the HTTP request?
There is nothing in the middle.
It's already
Correct. Exactly. Yeah. So I yeah, you're right. So I one thing that I just want to mention here, that I want also mention a lot when I teach at uni. For example, I challenge students to do the similar scenario. Let's say, hey, if you send me a link to change your grade from something to A, and if you succeed, I give you A. So so this is exactly the same scenario, and I know that there are some system in university that are vulnerable to this. I show that demo to students. It's vulnerable. So let's say you know the reason why. So we discuss later why it's vulnerable to this. And I give you a hint here is because developer didn't take care of this. So there's a way that developer can avoid this, but because they didn't aware about this and they don't care about this, then it's happened, right? So that's that one thing. And another example was also a long time back, but it's really significant. Were Sammy on MySpace. MySpace almost dead now, right? But it was the first. It's the first social network. And of course, MySpace have a very solid developer. They take care a lot of security, but there was attack happen by they already have a security prevention at the application layer, but the attacker they you see they provide some code over there, and this is the real code. It's not like simulate code. And you see what he did is that you see here the Java and then new line script, something like that. So when they do this, of course, the system will not allow JavaScript to run, but he do Java and then new line and then script, and then the server didn't detect that, okay, this is JavaScript, so the code go through. And the consequence of this code is that they affect like about 20 like a million user in 20 hours. So what they did is they propagate a Sami account and then do a friend automatically and just prop something like that, right? So yeah, so these two real world examples that I bring back to the discussion, like who should responsible for this attack and vulnerabilities. I didn't talk about legal here, but I just talk about like in general. So you may this is one common thing that people normally talk about, like the victim. So they say, okay, this is you because you clicked on the link. This is you because you do this, do that, right? But that's not fair. To me, it's not fair. Because like how can you blame the victim? Like so let's say in the PayPal example, like the user, the customer, right? So technically it's hard for the user. Or maybe you can say, okay, why the organization do not do anything like to filter things, have a firewall or proxy or whatsoever. Or maybe the internet provider, can you sue them? Say that, okay, how can, like, why don't you protect me from this kind of attack? I do not talk about the legal here, but I just want to mention one thing here. Technically, all of these responsibility were not valid. Even though they do something like that, it's not valid, because in general, the cybersecurity in general, they do not know what happened inside an application. Let's say firewall or cryptography or whatsoever. So technically, they cannot do anything. Even the, antivirus software or firewall, in this case, it's not possible to prevent this kind of attack happen, right? So it didn't work. It didn't work. And in reality, as I showed you before, right? The trend is that like more than 70% of software, the attack happen because of software vulnerabilities, and because the conventional security mechanism do not do not prevent this attack can happen, right? And another issue is that the vulnerability normally happen is not because of the network security, but because something in the application itself. And normally, because the application written by the developer, and that is because of the developer, they do not put that into account, right? And normally, this vulnerability normally is detected by the attacker, not by the security team or the developer itself. So that one is called zero-day vulnerability, and there's a lot of if you Google for zero-day, you will see that it's a lot of incident happens. For example, like just last year, there's Google they published, let's say, more than 40. The year before, like almost 80. What does this mean is that the software already released in the production, and then the hacker exploit the vulnerability inside, and then they do the attack. And then when they do the attack, like it's already happened, and is so after that, for example, the vendor, the software company, normally they will patch the application, but before the time they patch, the attack already happened. So that's why it's called zero-day, because there's like it's already happened, right? And in the trend, if you see here, it just happened and happened. So typically the developer they code, they develop the application, and there's something inside, but no one know. So it just release the application, and then the attacker know. The attacker try to do something, right? So let me show you one example about the careless of the developer lead to a real attack, right? So this is one example that is called buffer overflow. For example, let's say you check username, you check the password, right? So typically you get the data, username and password from the user, and then compare the data to, let's say you read the file or database, and you compare, and then you return true or false, right? So that is typical. So you are expert here, you developer here, you see that this is typical one, right? So of course, after you do the coding, you pass to the QA team, do testing whatsoever, everything went well, and then it's done, right? So do you see any problem in this like simple algorithm? Is there anything missing there?
Are we just sending that password as unencrypted request? I can use a million different things after that request you see your password.
Exactly, that is one thing. Another thing is input variation. That is another key thing that normally the developer careless and ignore. And if you see the picture here, right? So that is the second vulnerability, that input validation. Yeah, like what's the name? Adrian mentioned, like, because when you get the data from the user can put whatsoever, right? They can try many way, or they can put whatsoever. But if you didn't, if the developer just assume that the user provide the data they expected, then the developer will fail, right? That is input validation. And one thing that is missing here in this simple example is yeah, it's the input validation, right? So that is the most common mistake of the development. So when we talk with the developer, right? I mean, I do not work in the company, but what I read from the research paper saying that, like, so the developer may ask, when you talk, what wrong with this? What happened, right? I mean, if I do not do this, then you will fail the test. Because you cannot log in. If you provide not username password correctly, then you fail the test. And developer may not realize the reality of this. So, for example, the attackers not provide, like, they don't care about log into the system without username password. What they can do is that they can try to inject some malicious code, and that malicious code can run in your system and do something that bad to the system, right? So that is called buffer overflow attack. One of the vulnerability is buffer overflow attack, right? So I can show you one example of that. Let's say buffer overflow attack. And this is similar example. It's not exactly the same thing, but this is even simple than the previous one. Is that whenever you run the application, is you provide some input, they just print out the same input, right? The same output, the same. So this is an echo, and this is no input variation, right? So I have a video here. I can show you this video in this one. I just open here. So right now, this is the same slide I show you. So before the attack happened, right, it is the regular user, and then, I mean, if I put something, it just print out something, right? So that is very simple application. And now, because of the no input validation, the attacker can inject something, not the regular input, but another program. So, for example, in this case, it's create a script in Python, and then it put that script into that. And if you see that now, they got the root account, right? So it means that it's execute the code on behalf of the program, and then they got the root account, right? So that is one example. Yeah. So yeah, that is slide. Yeah, and I mean, this is the real code, right? This is real code that the attacker can try to do that to inject. So the next discussion I want to have here is this kind of buffer overflow attack new? It's not new. Can you guess, like, how old this attack happened? Like, Yeah, yeah. So yeah, about 40 years old, right? So a little bit, maybe a little bit younger now, but it's a mid 80 or something, right? So it still happen. Um, but do you think that the buffer overflow is all like this, and the slide, the demo I show you is like in the past? It's like it's not happen anymore. So have you? Did you remember the WannaCry? So WannaCry was one of the 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 kind of the ransomware, right? And you know why? If you read the news, this is a buffer overflow attack because the developer didn't do the input validation. That's one example. The other example is web apps. Web app is also the zero bug and it's have a buffer overflow attack. It's old. It still happen. So why? The reason why. So this is one of the reasons. The developer didn't take care of this. I mean, one of the reason, not all of the reason, right? But I mean, at the beginning, when the developer do the application, they do not care. Okay, this is the security expert. It's not my job. My job is to make the application work, right? And this is something for the developer, for the security team. But I mean, because of that, right? So many of applications go in with that. But I mean, this is common because the developer didn't know about this. Developer also not get the training in security, and of course, um, even for example at UD right now, in the core curriculum, we do not teach security programming, like secure programming in class, right? Um, and of course of this, because of this, like of course the developer do not think like the hacker, right? So they don't care, right? And this is another thing, right? So even the problem was there. The developer didn't know, didn't aware, and it still happened, right? So if you recall, my talk is about software security. So I mentioned about software security, and my second part is hacking, right? So the question is why developers should know hacking, and I mean connected to the previous one. Um, of course, if the developer didn't know, like how this, if you let's say if you forgot to do the input variation, what happened? And maybe the developer do not focus about security. They of course they focus on functionality first, right? But they ignore about the security. So that's why the software is vulnerable. Um, so hacking is not just to hack, right? Um, so hacking is to, as I mentioned in a lot of my hacking exercise, I told students, okay, if you succeed with hacking, you will know a lot about the system, and you learn a lot about how the system works. For example, in the SQL injection attack, I will show you later. Like if you type just one uh, character wrong, of course the attack will not happen. You must make the attack happen if you do everything right. So you need to understand a lot of things, and you do a lot of um, uh, related technique. For example, how to do reverse engineering in C code, or how you decompile the program, how to do a lot of stuff in. So I mean, not hacking is not, I mentioned here, is not attacking, right? So you just want to know about this kind of technique so that you know better. And my belief is that if you at the hacker, you can defend all of these attacks together when you code, right? So that is something different from the traditional development that okay, you do some development and then you pass this to the security team to do the pen testing and do some stuff, and then you come, hey, you missed this, do this, right? um, and I mean that is still the trend, I believe, one of the trend. But another trend is that 0-day vulnerability is still there, right? So so it's work, but it's not complete, solution, right? So there is another approach in software development, in that like secure development life cycle. This means that like so instead of you leave the security testing and validation for the security team, why don't you do that at the developer responsibility, or at the beginning of the phase, not at the end of the phase. So in that case, the awareness will be higher, and then the application may be more secure, right? So with this, I, as the educator at UD, I developed 2 courses related to this, and I call that like built-in security mindfulness for software developer. So I have a 2 course. One course is software security or language-based security. I call that language-based security because we use a lot of technique in the language, programming language techniques. So for example, like how to do the static analysis, how to do the dynamic analysis, how to monitor the code whatsoever. So it's language-based security. So that course is mostly about doing hack to application, so that they know about, if you do not take care of this, what can happen, right? And then the other one is secure application development, that you build the application, but the student also be aware of this, the vulnerability inside the application, and how to make sure that your application are free of these kind of vulnerabilities, right? For the software security, that is one of the main thing. The rest of the time I talk with you today, I share with you today, is I mean, I give you the student the possibility, hand-on exercise to do, to identify the vulnerability in the given software, so that they have uh, the white hat hacker, so that they know how to hack to the system. And then after that, when they know how to hack the system, they know how to protect the system by doing that, right? um, and these are some hand-on exercise, hacking exercise, that I provide in that course. Like for example, the data race problem. Have you heard about data race? Right. So data race is a problem that is happen like very common in, especially in concurrent programming, like where you share one like memory sharing, but you didn't synchronize between different thread. So with that, like when you update something, it's unsynchronized, so it's not, it's inconsistent in the data, right? And the exercise I gave them is that, okay, I give you an account of that amount of money, like $30K, and one one car costs like $30, but I'm asking them, at the attacker, can you hack the system to buy 2 cars instead of one? So when they know the problem, they can do this, right? So the at the beginning is very challenging, because how? Because whenever you buy, your balance is to zero, right? But like when they know this, so what they have to do is that they figure out a way that they exploit the data race problem. It means that like they need to find a way that, okay, you connect to the server, but then you just buy one, and like something like you didn't check out yet, the other one you also buy, you didn't check out. So when you check out one, is 0, of course, but at the other one, because you already buy one before you check out, so you are allowed to have two, something like that. So it demonstrates the data race problem, and then I go ask them, okay, with this problem, how you fit this problem, and then we do that way, right? So that's one example, and I have a lot of example, of course, like in Android, Java and Android application. We talk about how we do the reverse engineer the Android application to inject some code to protect the application. But for follow attack that I show you over there, um, you see the code that I showed you earlier. Um, Given that code is, you see that it's simple, but it takes student about 1.5 weeks to build that code, because they need to understand a lot of things. For example, how they look into the memory of the program, to debug the program, to look into the memory, to get into the memory, and then how to override the memory in C or whatsoever, right? So a lot of stuff in there. Simple hacking in PHP and MySQL, and then more about session hijacking or authentication with session, SQL injection, cross-site scripting attack, SQL injection together. Cross-site request forgery attack is the one that I show you on the PayPal example. And then web application in general, how to deploy that in the HTTPS, for example. So these are some examples that I have at UD. And then I have another course that secure application development. So this one is more at the development side, and I try to introduce the security issue at the beginning so that they have a hacker mindset. However, due to the time constraints, I cannot integrate all of the hacking into this class, so it's not there. So students take one of these, they do not test both, so they still not have if they take this one, they do not have a like real hacking technique experience. If they took the other one, they do not have a development one. Even they understand the issue over there. They know how to fit the problem. So in the first class, I give at the beginning, I do not give them the program, right? Depend on system, but for some of the program, they do not develop. They just, I give them later on. I gave them the code, and then they just correct the code because they figure out where the code have problem. So they do not have a like development experience. This one, they have a development experience, but they lack they know the problem, but they do not have a real hacking thing, right? So so recently, I just shared with Chris that I just developed another course right now. It's happened right now. I'm on sabbatical leave from UD, so I visit UC at the visiting professor over there. So I developed a new course that is combine the hacking and development into one. It's called Web Application Programming and Hacking. So I want to combine these two together into one course, and it's focused on both development and also hacking. So today I want to share with you some experience about that. And right now there's more than 100 students attending, and so far they like the approach for this one. So in this, they of course they will learn how to develop application from front end, like basic front end and then basic back end with MySQL, and then they will learn about if you do not do this, like how can the attacker can exploit your application and do that, right? And together with that, we will introduce the secure programming technique, and we do a lot of hand-on labs and also the hackathon and then some projects, so that they so in the project normally they learn the basic technique, but they also do the self-learning to learn, some of the state-of-the-art techniques so that they can apply into their project. So I give you one example. By the way, a question so far? Do you have any questions so far?
Sure, I have can you define for all of us the difference between dynamic?
All right. So yeah, the dynamic analysis, in simple way, dynamic analysis is a way that you run the program and you will extract something. For static analysis, you do not run the program, but you read the code of the code or whatsoever. So that is, I think that is the different way. But in dynamic program, we have different techniques. In static analysis program, we also have different technique. So for example, in the static analysis, how you analyze that? One of the traditional way is to read the program, put into the abstract syntax tree, and then extract the node and the root or whatsoever. That is one way, right? And of course, you have another way as well. Like for example, you can do interpretation. So you do not run it, you don't do it, but you just say, okay, this is the one line of code. Then I will translate into this, and then I do some analysis. So for dynamic analysis, it depends on different applications. So for example, I do in my research, I do dynamic analysis for web page, for example. So what I'm doing is that I develop a browser extension so that whenever you run, I will look into the behavior of the web, something like that. So.
For that side of dynamic analysis, are there tools that you recommend? Have your own browser, thinking of like Lost has this app tool, that one, just a form,
I do not have a recommendation, right? But I know, I know OWASP, they have some tool that you can do. Or even like, for example, the pen testing tool, they have some tool that you can, that is one of the student project they have. For example, they compare different tools that, let's say, what they did is that they use the vulnerable website we learned in the class. They put into the tool and then they compare, okay, this tool detect like 100%, this tool detect some, but I do not have recommendation. No. Yeah.
last question. Focusing on buffer overflow, one of the bigger problems. Is it specifically input validation that's the largest cause of buffer overflow problems? What is like, as developers, we're worried about, hey, we don't want to have buffer overflow. What's that?
One tip that I repeat every time with student in my class is one thing that the developer, as the future developer, you have to remember, and it's still it's still valid, is that never trust input. So whatsoever you yield the input, that input could be from the user, could be from database, could be from file system, whatsoever is not controlled inside the information flow of your application. It's not generated by you. It's from somewhere else. Do not trust. And of course, depend on the application. Let's say in the web application, you do differently. In the C application, you do differently, right? PHP code, you do differently, right? So, but the mindset is that if you use the data from somewhere else and you didn't validate that, sooner or later you have problem. I'm confident to say that. Yeah, you do not have problem now, but sooner or later you will have problem. So that is my hope for this course development. Like they need to, as the developer, future developer, my student need to know that, okay, these are the data that not owned by the developer, is from external. and you need to validate that data before you use, right? Otherwise, you will have problem.
Let's say I'm an API developer. I have another team in the same company, they're the web front end. Am I okay to trust the data from
I mean, that is a bit, yeah, you're right. That is another problem. Right? Trust is very I mean, by the way, I do research on this problem as well, not teaching. So my target for my research will be zero trust. Zero trust means like I don't want to trust anyone, even myself, because I cannot guarantee that I do not have a mistake. So in a long-term solution, you should not trust anyone. That is my research goal. But I mean, how? That is another step. But back to your question, I mean that is not good assumption. So I have another talk about research. So I give you an example. Let's say you include the code from not like maybe the same team, but maybe from Google.com, for example. And people normally, okay, I trust the big company. They do this good thing. But you know, we cannot rely on that trust, right? So you need to validate anything before. So in my opinion, I think if the code or if the data come from outside, we need to validate that, even though it's from same team, from same company, even from you, from yourself. Because like let's say if you have a code and you didn't take care on of the exception, right? And I mean, let's say you return something like, for example, null or some undefined, right? So then it's you crash your program, for example. So that is simple example that you should not trust yourself even, right? So input validation will be your take care of this. So okay, so we have about 15 minutes left. I give you some demo or case study that I welcome you to join to do the real hacking to see. So for example, this is the one that back to the same similar example in my current course, like web application programming and hacking, right? So this case study that they will develop a simple system that check the username and password and then connect to the database, right? So normally they write the code like this, like, you know, select something from something, where something, right? And then what I asked them to do is that think at the hacker. So if you do this code, and I mentioned to them that, okay, this is the way that normally the code is insecure. So I give them, okay, if it's insecure, think a hacker, what the hacker can do with this, right? And then they do some attack, and then I will give them, this is different approach that I provide the hackathon for them to do the real attack. It's not in their code. It will be in my code. So of course they do not have a my code. Or I use some real application as well. I deploy some real application and they do the attack on this to understand. And then they will, after that, they implement the secure code. So normally 2 versions. So that is the current course that I'm offer at UC. Yeah, so for example, this one is the insecure code. So in you maybe expert here, you know, this is no input validation, right? And no input validation. So normally I discuss with them, okay, this is one. No input validation. You agree with this, right? Because there is no input validation. Attacker can inject SQL code. Yeah. Attacker can inject JavaScript code. Because no input validation. So basically the attacker can inject whatever they want, right? So yeah, so I discuss and then I give them some demo. So let's say in this application, it's not only vulnerable to SQL injection attack, but it also vulnerable to cross-site crisping attack, where the attacker can inject both code together to bypass the system but to steal some information as well, right? So this is the shell attack, right? And then I give them the real the follow-up hackathon exercise. So for example, if you have computer or you have something, you can try with me. This is the cloud app. Like if you want to try this, so I give them some exercise like different level. So the first level, level 0, is the same that they do the shell attack, right? The first one, not the second one. The second one is in case I just discovered that UC they have a firewall, the application firewall, that once you put the SQL code in the URL, they will not let you do it. So so that one, if you go there, you will have something like that. So if you have a awahs-hackathon.hus cloudapp.azure.com, and people online, you are welcome to do this, to do the attack, or you can do it later if you want. So yeah, and of course when I do this, I need to make sure that they will not do the real attack in the real system, because that is like, it's not legal, right? So for the first level 0, it will be exactly the same system that we had before, but if they do something like, it will work. However, what I want them to do is that they need to put their name as well in the system, right? So for example, the outcome that I want them to do is that they need to put the name. Of course, the name is not in the database, but they put the name over there, right? So they do something like that. So so that is one example. I yeah, I can show you here. Oh. All right, so all right. Have you ever tried this before? The SQL injection attack, right? So SQL injection attack, like for example, in level 0, like normally you put something, let's say, and then you end with that one, and then you do all 1 equal to 1. So 1 equal to 1 will return like everything, right? And then of course you need to put something like comment, otherwise it will not work. If you do not have this, it will not work. And then you can put whatsoever, right? So when you do that, you can log into the system. So that is level 0. It means that is the same the code that I asked them to do. But then I challenge students more. So let's say if you do exactly the same thing, let's say you copy this again, and then they do, let's say, level 1. And then they try again, exactly the same thing, right? And then whatsoever. So it's will not work. And then I go challenge, okay, why it's not work? So that is lead to, like, for example, like level 2, level 1. So they have to I mean, as I say, like hacking is not just only now how to hack the system, but to understand. So I challenge them, okay, so you have to figure out something to do that. So let's say one thing that I ask them to do is that, let's say if you try something like not valid, for example, and the vulnerable software normally they so they will sometimes they will put something over there, And one thing that I asked them, I challenge them to do is, let's say, for example, if you try single code, it didn't work, you can try double code, because that you do not know the back end, right? So just try. Hacker have to try different way to do that. So if they try something like that, they could see, okay, there's some syntax error, something like that, and then they figure out more. And then I challenge them more. Okay, it's with this one, it still not work. Why? This one, let's say, for example, this one, it still not work, and they have to figure out why it didn't work. So then I give them some guidance. For example, it's typically it's not work because when you do like 1 = 1, it could return all of the records in the database. And of course, if the when we do the check-in, you do not compare with multiple, you compare with one, right? So they had to try another thing, like for example, you do like limit 1, for example, and in this case, it will work. And that is level 1. And then so level 1 and level 0 is very simple, but then I challenge them to do like attack at level 2. So level 2, if you do this, it will not work. And in level 2, what I will ask them to do later is, yeah, maybe I just pass something. Yeah, so in level 2 is similar to that. But if you put like either level 1 or level 0 or level 1, it didn't work because we already have a skill code, and they will do the skill code later. So I will ask them to do a route, right? For example, we have something over there, and then you have to figure out, okay, is there any place that have a vulnerability? And then they have to inject the code to read the data from the database. And then after that, they will read the database, they read the username and password, and then they log in with that username and password. So that is more advanced code for them, right? So I walk them through this kind of stuff, like, okay, how you inject the code to read the if you discover that, how you read the code from the database, and how you get the data, the username and password from the database, things like that, right? Yeah, so I have only a few minutes left. I don't know, you open to stay a little bit longer with the demo? Yeah, so put some code, right? So, and I asked them like how to detect this, like do step by step, right? And then the first thing is I asked them to discover like how you inject some code to figure out the backend code, guess the backend code, and then inject some code to figure out the backend code. For example, one thing is like when we do the select, like how many columns in the backend, and then you have to figure it out step by step. And then from that, we do something like, okay, we guess, because we do not know, as the hacker, you do not know the code, you have to guess, right? So you normally you use the union, so that you combine that thing together, and then you do something, and first you identify how many columns in the back end. So for example, here I show them, for example, here, click on here, for example. So it's yep.
Let's talk for a minute about economics or development. I would debate that majority of companies know the best security practices. Oh, thank you. But it's cost prohibitive to not only do that, but also establish testing department to make sure everything is to spec. What other solutions can you offer to the business overall to say, okay, we cannot afford to do that because we'll never meet the budget or the deadlines? What else can we do?
I don't think I have an answer to that question. It's beyond to my knowledge or my expertise. But I mean, what I'm trying to do here is that I at the educator to to produce graduates to your companies I mean, what my hope is that I want students to aware of this. So when they do the development, so they need to integrate that. Even though you have a deadline, you have a business constraint, you have a budget constraint, but I mean at least they. My hope is that if the developer they instead of they just do like uh, without input validation, they do the input validation at least to make sure that the problem will not be there. Right?
Thank you. Some of it could be knowing how to use the right libraries that already solve a lot of these problems, like SQL injection, where if you're using parameterized queries and stuff like that, I mean, I think that's the only real answer to that.
Yeah, exactly. So for example,
Yeah, I mean, I think that's part of the, finding the right tools that will help you there. I would say that we are seeing more so for companies who are producing products that sell those software products. Bigger companies, so if they're selling them to larger companies, those companies are now saying, you must provide for us proof that you have secure software development life cycles. You must provide for us proof that you're doing testing. We want to see the last time your software team did a tests and what were the results and how did you overcome that and what is your security and how often do you meet to discuss security and what tools to use. So they're actually starting to demand that of the vendors. So I think that is one way, we won't buy your tool if you don't do it the right way. But that's only one set, obviously, of applications. So for companies who are internally building applications to be used maybe by their customers or their users, I think there's still lots of gaps there. I think people are getting better at the web side of things. Like we're kind of more and more, hey, we have our web, our input validations and all that kind of stuff. But the API side of things, which is why I specifically brought that up, I think there's still a ton of gaps there. There's specifically an API security group that was formed with some folks from the API programming team at Kroger and a few others. But even Coinbase got hacked big time through a API, not properly authorizing the API. So again, talking about having a session, you can you have a valid session, but then you can change use Postman or whatever and start messing with your API and your valid session, and you can do all kinds of things. So there's the awareness is a big part of it, but the last thing I wanted to just quickly say on that is that when people get actually hacked, I mean, I think this, and they see the cost of that, that is where they put in. We did have a customer who had a ransomware attack, and their security processes improved dramatically after that attack. So sometimes it's just a matter of suffering the pain to realize, yeah, you've got to do something.
Let's see here. They want to know if it's possible to learn these techniques without actually attending university, and are there any resources for people who are already working in the field or who otherwise cannot take your class?
I believe there's a lot of online courses in hacking, but I'm not sure if they have something like combine programming and hacking together. I didn't do the research yet, but there's a lot of resource online. Like for example, I think Coursera also have a lot of cybersecurity courses for the folks from not going to college. One thing that I personally I want to do is that I want to collaborate with some of the community to offer this as a online thing for people not at the university. That's my plan, but I'm not sure. But yeah, the answer is a lot. I know a lot of online resources. Like for example, the EC Council is the one that I collaborate with. They have a lot of online course for this kind of stuff.
Another quick OWASP, if we're not familiar with the OWASP, they have a top 10 list. That is highly recommended to keep up the current significant activities.
Yeah, so my course is based on OWASP top 10. Yeah, so so for example, in software security, I introduced that, and most of the web application, this one, especially this one, is based on top 10 or web top 10.
You mentioned that antivirus software doesn't help with this, but there's some 0-day endpoint protection software that's offered to companies. Does that help with any of these vulnerabilities?
I'm not sure there is a tool to avoid 0-day vulnerability. I think 0-day vulnerability is just general term of that your application have a vulnerability, but the whole team didn't know. And then it's in the production, there are attacker out there, they discover it. So I'm not sure if there is a tool to make sure that you do not have a 0-day vulnerability. I think the way to do that is to make sure that we have all of the security requirement and then implement that from the design to the implementation to testing, not just for at the end you do some testing at the end. But I do not have an answer to that question. I don't know.
Anybody else have a question?
Couple of observations. With what you were talking about with the SQL injection reminded me of a couple of experiences I had at a prior employer. First one was developers can do harm when they try to be good citizens. Like it's a developer's desire that when something goes wrong, you want to be helpful. You want to provide as much meaningful feedback as you can about what went wrong to the user without necessarily thinking about the fact that you're providing information about the internals of your system, or you may not be overtly providing like credential information or something like that, but you may be providing information that lets them narrow down their attack vector.
Right. Yeah.
And then the second part is more overt. We actually had some contractor code that when they would dump exceptions, like lots and lots of exception detail, it was including information about our SQL administration credentials
Correct. Yeah.
dumped straight to the screen.
Right.
So
Yeah. So that is one topic in my class, saying that okay, this is also like during your development, you do this for debug, but then you forgot to comment out that debug information, then that is a big problem as well, because the hacker can learn a lot from them, right?
exactly what it was.
Yeah.
Helpful to us,
Right.
like in seconds, helpful to us as developers. Lots of detail.
Where the problem is. Correct. Yeah.
Thank you.
Yeah.
I just wanted to give you one example of what happened in one of the previous places where I worked. So there was not much importance given to security at that time. And suddenly we see a tweet out there with somebody hacked the system and put the data on tweet and put it in public saying that, hey, this company is doing all this. Your credit card information is available to everybody. And that's when they started giving more importance to this. So yeah, these things happen.
So before next question, maybe I just want to summarize about, I believe that the way that we integrate the security and development will be helpful for future developer at graduate. My students have a very positive feedback, even they work after graduate. Still connect with me about this kind of stuff. The real issue is that like in most of the CS curriculum, we do not have a secure programming in the class, or in it's not required. It's there. Like for example, at UD we have that, but it's not required. So it's only people who are interested in security that they take these classes. And then unfortunately, the future developers still write insecure code because they do not aware about this, right? So
Well, there's one answer to the question. If we could get our students trained in it first, maybe they would do it more, right? But unfortunately, Yeah, you don't even see it we're not seeing it at the educational level either. So hopefully that will change in the future.
Yeah. So I try, but I mean, yeah, I try to do something. For example, I want to integrate this into some basic classes, or maybe, integrate some of these course, or maybe I also open to, the industry to see, okay, how can we do together, something like that. So
That's great. Yeah, thank you very much for your time, Dr. Phung. Appreciate you coming and talking to us about hacking and software security. Appreciate everybody for coming and all your questions. I wanted to let you know that our next Lunch and Learn session, which date to be determined, but it's going to be on serverless data pipelines. So if you're interested in moving data one place to another and transformations and some of the, it's going to be based on a specific case study, but we're going to try to generalize it to both Azure and AWS. So the world is a lot about AI, and AI needs a lot of data these days, and so do companies in their reports. So should be a good talk on serverless data pipelines coming up in a few months. Again, thank you very much, Dr. Phung. Let's please give him a hand. And
my pleasure.
thank you all for coming.
Thank you, people join online.
Yes, thank you.
Thank you, everyone.
Thank you very